All right, Hugo Bown Anderson here, Head of Developer Relations at Outerbounds, and I'm really excited to be here for our webinar with Thierry Wendling from Atomi, who is Head of AI and Machine Learning at Atomi. Hey Thierry, how are you?
Hey Hugo, yeah, very good, thanks. Thanks for inviting me on this webinar. I'm really happy to be here, and yeah, very excited to talk about some AI and data science things.
Absolutely. And this is the first time I've done something like this with someone who's in the same city as me. So we're both actually in Sydney, Australia currently, aren't we?
True, true. We could have been in a coffee shop right now, but
Exactly.
it could have been
Exactly. Um,
yeah.
So let's jump in. To set the scene, I'm really excited about everything you do at Atomi. So I thought you could just introduce in a few words what Atomi actually does.
Sure. Yeah, so Atomy is an online learning and teaching platform, providing curriculum-aligned content and lessons to high school students and teachers. Um, and we also provide knowledge testing tools and analytic insights to help teachers to efficiently manage their class and to help students to efficiently learn, test, and prepare for exams. Um,
Fantastic. And it's primarily high school, is that correct? Currently,
yes,
or
yes. It's primarily Australian high schools. We do have a little bit of exposure in other similar markets like the UK, and I think we started a little bit in Canada. But yeah, primarily high school years from year 7 to year 12, basically.
cool. Well, this does sound like very fertile ground for data science and machine learning and AI to, particularly because it's online, for it to be impactful. But I'd love for you to tell me kind of what makes data science and AI at Atomy specifically important.
Yeah, sure. I mean, like you said, it's an online platform, so everything around data and data science and machine learning is just like by nature is going to be useful for provide a really good experience on the platform and a lot of analytic insights and things like that. But the specificity of Atomy is that we also create a lot of learning content internally that we share with our teachers and students. And so we have processes to create content, and obviously with the latest progress of AI technology, uh,
Mm,
specifically generative AI, it's actually a really good fit to create content a little bit more efficiently than we used to do. So yeah, there's basically two big use cases for data science and AI at Atomy. One is content creation, and we do create different type of content, so text and images and videos. And the other one is just like more standard platform management things, right? But there's also some specificity with the fact that our users are students and trying to learn effectively and prepare for exams, and that just makes some of our requirements a little bit high in terms of quality and reliability and things like that. So yeah, in summary, yeah, we use data science and AI at Atomy is very important for, first of all, for us to operate the platform well and make it a nice experience to the users and always ensure like high quality to the students, like under stress when preparing for exams. Um, and then there's some more recent things around and more innovative things around Gen AI for content creation. But
amazing.
in any case, whether it's content creation or helping the student to learn faster, yeah, the consequences of low quality or unreliable software systems are potentially high and I mean, yeah, potentially like quite a lot of consequences. So this is where applying careful data science and MLOps practices is important at Atomi.
Absolutely. And I know you've been using Metaflow and Outerbounds for some time. And of course, the first time we met and talked about it, we had lunch in a pub, which is a classic Australian lunch on a Friday. But
Remember
before
that,
you
yeah.
started using, yeah, before you started using Metaflow and Outerbounds, what tools were you using?
So at Atomi specifically, we were using GCP, so Google Cloud Platform, and so their own tooling around MLOps. So Vertex AI was the main service that we were using to manage the MLOps lifecycle, and so that would be the equivalent to Outerbounds. Yeah, so we were using Vertex AI to orchestrate machine learning pipelines and serve models to production and things like that. Yeah. Before Atomi, in previous organization, I've also used so by the way, the Vertex AI is based on Kubeflow. I mean, yeah, at least at the time, it was just like a wrapper. It was just like their own version of a managed Kubeflow. And yeah, and so prior to Atomi, I also had experience using SageMaker quite a bit, and SageMaker pipelines and that kind of services as well.
Fantastic. And so adopting Metaflow and Outerbounds helped you with a lot of these things and replaced a lot of the tools you were using. But I'm wondering in terms of the features, what Outerbounds features do you now find most useful and why?
Yeah, so there's quite a few. I think the first one is just like the really user-friendly interface of Outerbounds, and the data scientist that I manage seems to really like it, and they learn quickly, and they become autonomous like quite quickly. And that's because it's all like Python, like simple Python code, which is what data scientists are used to. And it's quite easy to use. There's not too much complexity on dependency management, which can be true for other frameworks like Kubeflow, where the data scientists might have to deal with Docker containers and things like that. Some of them have zero or little experience with that kind of technology. So yeah, I'd say the first nice feature is it's just like it's really friendly, really data scientist friendly user interface. Also, the ability to quickly test some data science logic or flow or pipeline locally with like simple setup, I think is also quite nice. And what comes with these local experiments is there's also quite a lot that come with it in terms of being able to track the experiments and inspect the different data and artifacts generated at each step of the pipeline, even though you're running all of this locally. I think is quite amazing. So essentially the ease of doing some local experimentation, but doing it in a way that, yeah, it's still following some good experimentation practices, and you can really track everything, and everything is versioned, and you can inspect in details the outputs and artifacts, I think is quite nice. Then probably my favorite feature about Outerbound and Metaflow and what really for me is like a time saver in terms of operating a data science team is, yeah, the ability to take local experiment to the cloud, like the ease of scaling local experiments to the cloud using Metaflow and Outerbounds, and it's just like super easy. It's little changes to the code, and yeah, you just move from like, experimenting on a small data set, a small space, a small region of the data space, and then you're like, okay, I'm happy with these results, and I want to scale that experiment and put in the cloud and run on like bigger compute instance and things like that. Yeah, it's just like impressive how easy it is to do that with Metaflow and Outerbounds. And also considering the pain of dealing with dependency management with Python, programmers coming from other programming language and runtimes will tell you like, Python is a pain for dependency management compared to, JavaScript or other languages.
And they'd be right.
And they'd be right. There's like, the thing with Python is like, whether it's for dependency management or other things, there's always like 10 different ways to do things. And that make it a little bit difficult to agree on standards within a team and a company and stick to that. So yeah, so back to Metaflow, I think, yeah, like you build a local pipeline, machine learning pipeline with like some sort of dependencies, whether they are in requirement.txt or managed by Poetry or whatever. And then, yeah, taking these to the cloud to run on Kubernetes or something like that is potentially like 2 extra lines of code, right? Maybe 1 or 2, right? And that's just so good. And that's for me, one of the main reasons that made us move away from Kubeflow. Because, yeah, otherwise you have to deal with the life cycle of Docker containers and things like that, right? And that's just a little bit more time and resources involved. The other thing that I really like about Metaflow and Outerbounds is the data store that come with it, and the fact that, again, so you're running an experiment, everything is versioned. Okay, all the artifacts, all the data throughout the steps is versioned, and there's a complete lineage of this data and artifacts. And from my experience, when I was working with other frameworks like Vertex AI or SageMaker, we had to manually implement this lineage. Okay, and more recently, and also, I think at the time there was no offered solution for a data store as part of the pipeline service. I think now that has changed a little bit, but yeah, essentially, yeah, the fact that, yeah, everything is stored like all data throughout the pipeline steps are stored in a central store, and it's easy to access data for specific versions or tags or labels. I think is for us really, really useful. For example, like you might have, like typically you would have in your MLOps lifecycle, you'll have some training pipelines, okay? Yeah, and you can store, like, obviously, keep track of your training data, testing data, models, things like that. But then you also have typically an inference or prediction pipeline that is scheduled or not, that you can just trigger at any time. And this prediction will be stored in the central Metaflow store. And that's a form of caching, right? And it's so useful because then we have a lot of application that plugs into the store and is able to very quickly retrieve this data for specific model identifier and dataset identifier, anything. And those applications then can just do very simple things like calculating some metrics or some evaluation and things like that. But so you don't need to recompute the predictions. They cache in the Metaflow store. So that's very efficient, especially when the predictions needs to be computed on GPU instances. Okay, you don't want that. You might have a streamlit dashboard for in-depth model evaluation and error analysis. And originally, actually, we had that, right? Like we were pulling the model, pulling the data set, recomputing. Or you can do caching, right? But wherever your application is running, at some point your cache will be emptied, right? So having this shared cache outside of your application, I think it's just a pretty it's just a good software engineering practice in general. And using Metaflow in our cases made this like really easy, basically. So yeah, the data store basically is super useful. And yeah, I think those are some of the main really good features that I think are really useful to data scientists.
Very cool. So just to recap, it's the Pythonic nature of everything. Scientists get to write Python code. The ease of local development, testing, scaling to the cloud, dependency management story between local and cloud, and the data store. And you mentioned, moving away from tools such as Kubeflow, which I think Kubeflow has its uses and it's fantastic for a lot of things. But I think what we're hearing is that it's not necessarily something that scientists or machine learning engineers should be using on a daily basis and writing configuration files and that type of stuff. They want to be in Python, in notebooks, then scripts, pushing things to production, triggering events. So making scientists as productive as possible, which dovetails nicely into what I wanted to hear about next is just how do you think about making data scientists as productive as possible? And how does Outerbounds help you with that?
Yeah, so I mean, this is obviously a complex question. I think everyone I'm just going to share my personal opinion on this. There is some guidelines on. There is some more and more guidelines on data science and best practices and things like that. But I'm just going to talk about my personal experience. So in my opinion, for data scientists to be truly productive, they need to be able to build data science solution, obviously quickly and independently, but they need to be able to build data science solutions that are practical and that can be quickly shipped to a production environment, so engineered and shipped to a production environment. And this is, to me, from what I've seen so far, can be the challenge, right? Because you either have, I've seen environments where, everything is, you use a data science platform where everything is automated, everything is abstracted away from the data scientist, and there's little flexibility, there's little the data scientists can change or do themselves. And so that can be good, but as soon as the data scientist has like a new use case or something different like this, the platform is not flexible enough. And yes, so that can be a blocker to addressing new use cases. And then I've seen platforms where there's it's almost too flexible and there's not enough tooling and support to ensure like best practices are applied, and or there's no platform, right? And the data scientists just do things in Jupyter notebooks or whatever, And the solution that they provide is just like so far away from being good enough to ship to production, right? So for me, yeah, like making a data scientist productive is providing them with a really good user experience for building, developing, building, testing machine learning models and AI models, but in a way that by default, there's a lot of the best data science and MLOps practices applied to the flow in the background. And so, yeah, meaning that, yeah, the data scientists work independently, but at the end of the experimentation phase or development phase, their solution have by default followed the best practices, and their solution is kind of ready to be integrated or shipped to a production environment. So yeah, so those by best practices, I mean, okay, like you're doing some development and you want that the best practices on experimentation, which is like, yeah, tracking, versioning, storing, all of these things are applied by default. You want that somehow, yeah, your code is well structured and organized and linted and tested. And you just want to make this like super easy for the data scientists to be applied. So I think, yeah, working in that kind of environment will make the data scientist productive, I think.
Great. And from your previous response, it sounds like Outerbounds really does that for you in a variety of ways.
Yeah, so all the features around yeah, the ease of dependency management and versioning and complete lineage between artifacts and storing in a central store. Outerbounds also does some automatic linting and things like that. Also, the fact that it makes it easy to scale the experiment on the cloud, because sometimes that's another problem with the productivity of data scientists, right? You'll experiment on something small because that's all you can do, even if whether you're working locally or you're already working on some cloud environment. But then you're only looking at a specific narrow region of the data space that you're trying to work on, and then when you scale the experiment, like a lot of the time, new issues arise, right? So I think the ability of the data scientist to quickly, independently scale an experiment is very important and make them more productive, I think, because they will quickly reveal all sort of issues with the model or predictions. And yeah, rather than they were not able to scale, they give this to the machine learning engineer, this is being deployed to some staging environment, and this is where these issues are being revealed, because this is the first time that the experiment was, like, some testing was run at scale, right? So yeah, all these features and I mentioned about Outerbounds, I think, are what, in my opinion, and with our team, make our data scientists productive.
Awesome. So I'd love to dive a bit more into kind of what an ML platform should look like for a data scientist. But I suppose to set the scene for that, maybe you could just tell us in a few words what purpose do ML platforms actually serve? Why do we need them?
Yes. So again, this is going to be my personal opinion. I think there's a bit of variability on the expectation of what a ML platform should be. So in my mind, an ML platform and a good one should provide data scientists with the tools and automation to develop, test, deploy, monitor, and improve machine learning models powering software services, right? And the platform should make the data scientists able to do all of this and apply this life cycle at speed and to high quality standards, basically. And the high quality standard is important, right? So you want that the data scientist just comes and logs into some UI and just like plug and play and orchestrate things, but it's all very guided and it all follows some standards. It follows best MLOps practices. That's number one. It follows your company standards. Okay, so you need to be able to inject your company standards somehow easily in the platform. And that's why some too rigid platforms are not able to provide, and more flexible platforms like Outerbounds make this easy. And yeah, so the data scientist should be able to orchestrate easily all of this. But in addition to, hey, okay, there's a good, what's a good user experience? Okay, there's different types of users. So some of them want no code or little coding. Okay, and yes, somehow if that's enabled, that's nice. But there will always be different type of user or power users that want to be able to, at some point, to do things more programmatically as well. So that's also important to be able to do that. The platform should also enable, like you should be able to follow the orchestration at a high level, and make sure, yeah, all the metrics, all the tests, all the validation are passed and okay. But then if I want to go and inspect at the most granular level, some data or artifact, or some logs, okay, or traces, that should be possible as well. And often that's, again, another source of, another pain point, potentially, with some framework, right? So, yeah, in summary, it should be like, yeah, a good user experience that has a lot of the MLOps practices, best practices baked in the platform. You have the ability to inject your company standards, and you should have the ability to either do things in easily through a user interface or programmatically. You should have the ability to inspect all the logs and data and artifacts at the most granular level as well.
Great.
So that's, in my opinion, yeah, is a good MLOps platform that will maximize data science productivity.
Yeah, I love that. And you've really spoken to kind of what an ML platform should look like through the lens of a data scientist as well, and why. And I do think, although as you prefaced it by saying that this is your opinion, of course, and not everyone agrees on everything, but I think the way you've framed it, in terms of, requiring a good, slick UX, for data scientists to do what they do best, including all the details of, flexibility and lineage and having access to everything through the entire MLOps life cycle, a lot of people would agree with. And also you mentioned, the ability for data scientists to be able to experiment freely. And as you're aware, at Outerbounds, it's one of our core values that data scientists should be able to experiment freely. So I thought, to wrap up, a bit of a fun question, for you, Thierry, right? If you were to tackle any ML use case or AI use case in the queue, what would you be most excited to run experiments on?
Yeah, that's a good question. I mean, personally, like I enjoy working on use cases like recommender systems. Like I've worked on this in the past, and we're gonna have to do a bit more work on that at Atomi really soon. But something else that really gets me excited is video generation.
Awesome.
And that's because it's actually an important part of our content creation process. So we do generate a lot of videos. So currently more manually, although we do use, smart software platforms, smart platforms to be able to quickly edit the videos and things like that. But the creation itself is still very, manual and human resource demanding. And yeah, like I said earlier, the creating content is one of the foundation of our business. So yeah, it's something like really important to us, and it's something that takes a lot of human resources. So it's always a desire from us to use AI to accelerate that. And I think we started to have a lot of evidences of feasibility already since the stable diffusion and DALI and that kind of Gen AI models that can do text to image, basically. So we could start to understand already, at some point there will be something that makes text to video easy. And obviously there's been some recent, we suppose we can call this breakthrough, but just advance in that space with things like Sora from OpenAI and some other models from Meta as well. So, and that was pretty impressive, right? Because
and also stability video diffusion as well.
exactly, yeah. So I think in general, all of them has shown recently that the quality and the realism of the video that you can get just from text input is getting to a stage where, it's quite nice, and it looks like you would need little or much less editing than before to take it to your end state, your target state. And this is a challenge for us, right? Because everything that we generate at Atomi needs to be satisfying some quality standards.
Absolutely.
So that, we want that we use AI to generate videos, and then there's like as less as possible editing and modification. So now there's a lot of evidence that soon this is gonna be kind of possible. But like with every Gen AI technologies, I think it's one thing to experiment with it and create like a successful small experiment or realize that qualitatively, that can be done. But it's another one to scale this experiment and quantify the quality of the generated outputs and quantify the reliability of it as well. So this is always a challenge, and this is what I think will take quite a bit of good and creative data science to be able to achieve and to demonstrate that, okay, such technology can be integrated in an internal process that have high quality standards. And this is where, it's going to be a lot of data science to, obviously like make sure that these models are instructed well and things like that, but make sure that we are able to evaluate them in a quantitative way and not just by eyeballing some examples, okay? So that's just going to be, a lot of data science and pipelines, and I think we for sure will use Outerbounds to orchestrate all of this and ultimately try to evidence the cost benefit of such new technologies. And I think
Very
just
cool.
as a closing comment, that I think more and more this is how data science is going to be. Tools like Outerbounds to orchestrate it all and quantify things and evaluate and continuously improve, basically. So pretty excited about that.
Amazing. And I love that your future music, your dreams are around video generation, because as you know, I've worked in EdTech for a long time as well and done a lot of online videos and that type of stuff. The ability to automate some of that stuff and create that type of stuff would be an absolute game changer. And I actually did want to share for yourself and the viewers. I don't know whether you've seen, so this is our blog. You've seen our blog. We actually did some really fun work with stable video diffusion when it came out last year. And all of this you can do using open source Metaflow, but you can also do it on Outerbounds platform. You can watch a video we created there, but we also created this little app where you can create your own video. So let's say I've got a corgi there strumming a guitar at Machu Picchu. Let's say I want to make it street art style. Can do that. I actually want it in Times Square instead of Machu Picchu, and so on. And actually, I want a raccoon. And we can put him at the Eiffel Tower, for example. And all of this is using stable video diffusion in the back end. And at a very high level, to your point, these are kind of what our orchestration looks like, right? We have our prompts and themes, we load our data, we have our video generation, and we're actually using stable diffusion, then stable video diffusion. So text to image, image to video, put that in cloud storage, and then to the app. And as you drill down, you see the things, the affordances that Metaflow and Outerbounds have. You can automatically refresh your app with your prompts and themes. In this section, you're able to experiment, you're able to access compute, and you run reliably, as opposed to perhaps executing notebook cells, which are great for other things. To your point earlier, in cloud storage, you can access the data store and all your versioning. And then on the app side, you have this, you can monitor production using Metaflow cards in Outerbounds, and you have the developer experience that you're referring to as well. So I'll include this blog post next to the video also. But this is to your point, I think, of the types of things we want to be doing and the type of things that are capable now.
Yeah, and this is amazing. And it's a good reminder as well that tools like Outerbounds and Metaflow are not just for orchestrating like training pipelines. It's also for inference pipelines. I would call it like that.
Absolutely.
But often we think that like this is only to do some sort of offline prediction to feed into some apps, some data science app for evaluating things or experimenting things, right? But there's actually it's actually part of some machine learning, best machine learning engineering practices to think that even for an online service like a recommendation system service, often it's good to pre-compute things as much as possible. Okay, and that's where I think this is a good illustration of that, right? Even if you were to serve this in real time in a strict production environment, okay, you, if possible, pre-compute things as much as you can. And I think Metaflow will be such a great fit for that. Yeah, so good reminder of that with some cool image generation and video generation stuff.
Exactly. And this is to your point. I think a lot of people, at least in the cultural consciousness, think about ML in production as, being endpoints and REST APIs and whatever it is, right? As opposed to so much of it is batch inference, actually, right? So much of what actually happens. So it's very good to remember what your business needs are and what type of inference you need to do that.
Exactly.
And to your point that Metaflow is more than an orchestrator, like I hear Metaflow in my dreams tell me I am more than an orchestrator. And I joke, maybe you come to Metaflow for the orchestration, but you stay for everything else, from the data store to the versioning to the cards, to all of these things, to the event triggering. We didn't even talk about, you hinted at it, but the idea that you can have your training flows, when they wrap up, trigger your inference flows. And that's just one example. You can, have changes in your database trigger training flows to then trigger inference flows and so on, which is a lot of fun.
Yeah, so we actually use it. We have some flows that prepare data sets and push things to our labeling platform, and when this is ready, that triggers some post-processing flow that triggers training and things like that. So yeah, that there's definitely a lot more. It's definitely not just orchestration. It's a proper platform, a lot of useful features. For sure, we've been enjoying it a lot, 100%.
Well, Thierry, I've enjoyed every conversation I've ever had with you and really appreciate your time. And thank you for coming on and doing a webinar with us at Outerbounds.
Yeah, thanks, Hugo. I enjoyed the discussion. It was good to have a chat with you and the team. And yeah, thanks a lot.